Hi, today we are going to learn about gold number. We'll see what is gold number and what are its uses. So gold number actually this is a part of colloidal chapter. I have explained what are colloids and what are their properties in a previous video. If you want, you can have a look on that. I will give the link in the description or in the I button. So today we are going to learn about gold number. So what is gold number? Before knowing this concept, we need to know about 3 or 4 concepts. Okay, we'll learn this in 3 or 4 parts. So the first part is how lyophobic colloids are stabilized. So what is the stabilization? How the lyophobic colloids are stabilized. 2. How lyophilic colloids forms protective action on lyophobic colloids. When you add lyophilic colloids to the lyophobic colloids, they form protective action. They will try to protect that lyophobic colloids by avoiding them to be getting unstable. They will stabilize them. How it happens? Lastly, we'll take an example. After knowing these 2 concepts, we'll take an example and we'll see that what is the color of your gold colloid when it is stable. What is the color of gold colloid when it is stable, and also we'll see what is the color of gold colloid when it is unstable. So by seeing these 3 points, we'll try to explain what is the gold number. Okay, see, if you learn this as a concept, it will be very easy for you to remember. Okay, instead of going into the definition directly, I will try to explain you the concept, then we'll try to derive the definition, or we will create the definition. So what it says, gold number. First you have to know, assume that I have a gold nanoparticles with me. Gold colloids are there in a beaker. Consider a beaker where you have gold nanoparticles like this. What we are going to learn now is how they are stabilized. So we have gold nanoparticles. We call these gold nanoparticles as lyophobic colloids. That is your gold nanoparticles. So you have gold nanoparticles, which we call it as a lyophobic colloid. Okay. Yeah, we call them as a lyophobic colloid. Now how they are stabilized? How lyophobic colloid is stabilized? Your lyophobic colloid is stabilized. So we'll say about stabilization of lyophobic colloid. Okay, how that lyophobic colloid is stabilized? By zeta potential. By zeta potential. Again, regarding zeta potential, I have made another video. You can go and check if you have any doubts about zeta potential. Here I am going to just give a outline of how the zeta potential will try to stabilize your lyophobic colloids. Lyophobic colloids, because they hate solvent, solvent phobic hating. They hate solvents, hence they are not stabilized by solvent sheath, which in case of lyophilic colloid. Here lyophobic colloid are stabilized by their surface charges. Example, assume that this is one gold colloid. Assume this is a gold colloid. Okay, its surface charge is, let's say, positive. It has a positive surface charge. Likewise, assume another gold colloid, same one. It also has a surface positive charge like this. Now, if the intensity of charge is more, potential means intensity of charge is more. Let's say the charge is positive 50 millivolts. Because they are positive charge, I am representing as a positive. Let's say the charge is positive 50 millivolts. If the potential of the charge is more, what happens? These two gold nanoparticles will try to repel from far away. They repel each other from a greater distance. Now, what we call it as stability in lyophobic colloids is, I want that colloidal particle to be behaving as individual particles like this. They should be like individual particles. Okay, if they form together and form an aggregate like this, this is sign of instability. I want them to be like individual particle in a given solution like this. I want them to be in individual particles like this. Okay, not like this. So this is the sign of instability, this is the sign of stability. So to make them to stay away from each other, what I will do, I will increase their zeta potential. If the zeta potential is more, then what happens? They will try to repel each other from far distance. They will repel each other from far distance. Hence, the stability of your lyophobic colloid. This is how your lyophobic colloids are being stabilized. Now, we will see what happens or what is the reason which will make these lyophobic colloids to be destabilized. A reason for destability. So, for that, or you can say instability. What is the reason behind instability? Now again, assume that I have a gold colloid here, okay, like this. I have a gold colloid. It is been stabilized by zeta potential, and zeta potential is very good, so no problem. Now, if I add electrolyte, let's say I am adding Na plus and Cl minus, an electrolyte. Now what happens? This electrolyte, because your gold particle has a positive charge here, let's say your gold particle has a positive charge like this. It has a positive charge. When you add an electrolyte, this electrolyte will be ionized into Na plus and Cl minus. So whatever Na plus is coming near to the gold colloid, it will be reflected or it will be repelled because of the same charge, and Cl minus is being drawn near because it has opposite charge. Now the Cl minus will come near and it will try to neutralize or decrease the intensity of charge on the particle, because Cl minus is of opposite charge. When it come near to that positive charge colloid, that is in case here it is gold colloid, it will decrease, this Cl minus will decrease the, by positive and negative will form a neutral, so the intensity of charge will be decreased. So depending upon how much NaCl I am adding, the charge will be decreased. If the charge is decreased, there will be a decrease in, if charge on the particle decrease, it will eventually lead to decrease in zeta potential. It will eventually leads to decrease in zeta potential. Now what happens? Due to this, the colloids will come close, because zeta potential is less, they will come close and form an aggregate like this. This aggregation is the sign of instability. Now, what is the color of this unstable colloid and stable colloid? So regarding the color, the stable colloid will be in the color of red. So red color indicates the colloid is more stable. The color is violet, then that color indicates the colloid is unstable. How this color will indicate it is stability? You need to go and check my video on introduction of colloids. I will give that in a description. Okay, remember this. You need to remember 2 points here. One, your lyophobic colloid is being stabilized by zeta potential. By addition of, if the zeta potential is good, the particles are far away from each other. If there is an addition of salt to that system, now this salt will decrease the charge or zeta potential on the particle, which will leads to the aggregation of the colloidal particle, which is called as sign of instability. If the colloidal particles are individual in nature, then we call them as stable particle or stable colloid. If the colloidal particle are aggregated, we call them as unstable colloid. So when the colloidal particle, that is the 1 point. Second point is the color of colloidal particle when it is in stable form. It is when it is in individual form is red color. Okay. When the colloidal particle is in unstable form, instable form, aggregated form, the color will be violet. Remember this. So due to addition of salt, due to addition of electrolyte, there is a color change from stability red to instability violet. Okay. So this is the part of lyophobic colloid. Now we will see what is the protective action of lyophilic colloid. Yeah. So example for lyophilic colloids is any polymer or acacia something, any polymer in water will form a lyophilic colloid. Lyophilic means, lyo means solvent, philic is loving. Because this colloid is loving solvent, hence we call it as lyophilic colloid. Remember this. It is loving solvent, hence we call them as lyophilic colloid. Now protective action, we'll try to see here what is how the protective action of lyophilic colloid. So how is the protective action of lyophilic colloid? We'll try to see that. Now assume that I have a gold nanoparticle. So this is a gold colloid. This is another gold colloid. Now this gold colloid, we studied previously that these gold colloids are stabilized by the charge on the particle, that is zeta potential. This charge will eventually lead to the creation of the zeta potential and they are stabilized. Now to increase more stable, to increase the stability of this lyophobic colloid, we will add lyophilic colloid to the lyophobic colloid solution. So if you add lyophilic colloid to the lyophobic colloid, what happens? This lyophilic colloid will form a sheet around the lyophobic colloid like this. It will get adsorbed on the surface of lyophobic colloid. We have a gold colloid here, 2 gold colloids are there. The lyophilic colloid, if you add, it will go and adsorb on the surface of the lyophobic colloid, hence forming a sheet. Now this sheet is water loving because lyophilic colloid itself is solvent loving. Okay, if the solvent is water, I am calling it as a hydrophilic. Okay, if lyophilic colloid itself is a solvent loving, when it forms a sheet around the lyophobic colloid, this will convert lyophobic colloid, which is hating solvent, to lyophilic. Okay, not directly lyophilic, by adsorption on that it will increase the stability. Okay, assume that you need to remember 1 point here, that is, if the particle is loving solvent, it will be in interaction with the solvent and it will be more stable. There will be a solvent sheet formed around the particle, like the solvent sheet will be formed around the particle. This solvent sheet will protect the particle from aggregation. Same solvent sheet is absent on lyophobic colloid because they hate solvent. Now by addition of lyophilic colloid to lyophobic colloid, there will be imaginary, or you can say there will be virtual solvent sheet which is being created. Okay, because your lyophilic lyophilic colloid is getting adsorbed on the surface of the lyophobic colloid, it will increase its stability. This how lyophilic colloid will increase the stability of lyophobic colloid. This concept we call as protective colloidal action. Okay, this concept we call it a protective colloidal action. Now, we'll jump to the gold number. This is the prerequisite concept you need to have in your mind to understand the gold number. So, we try to see what is the gold number. So, gold number, the units for the gold number is gram. Any unit which represents the mass. So, I will write as mg, gram, anything. Okay, we will consider it as a mg. That is the unit for the gold number. Why? We will see this. So, what would be the gold number? Now, what happens? Sorry. Now, assume that I have a, you need to remember, yeah, before going to the gold number, you need to remember here I will be telling you some, or I will be taking out some numbers here like 10 ml, 10%, 1 ml. You need to remember these numbers. Okay, careful. So, assume that you have a gold colloid here. This is a gold colloid. Okay, gold colloid which is already stable due to the zeta potential. Now, to this gold colloid, I will be adding lyophilic colloid. So, to this gold colloid, I will be adding lyophilic colloid. How much amount? I don't know. Let assume it as some mg of lyophilic colloid is being added to the gold colloid. Now, what happens? This lyophobic colloid will form a solvent sheath around the gold colloid like this, and it will try to protect. Now, previously we know that to destabilize colloid, we need to add some some electrolyte. Now, after adding the lyophilic colloid, some amount, now I will add to this, I will add NaCl. What is the amount of NaCl I am adding? I will add 1 ml of NaCl with a strength of 10%. Okay, 1 ml, 10% weight by volume of NaCl is being added to this previously added lyophilic colloid to the gold colloid. So, if I add 1 ml of 10% NaCl to the previously added lyophilic colloid to the lyophobic colloid, now what happens? This lyophobic colloid will not be destabilized. We previously studied that it will get destabilized by addition of electrolyte. Now, in this case, due to addition of electrolyte, it is not getting destabilized. So, because we added some X amount of lyophobic colloid, this X amount of lyophobic colloid is stabilizing this this X amount of lyophilic colloid is stabilizing the lyophobic colloid. What is the amount of lyophobic colloid we have taken? That is 10 ml. So, assume that you have a 10 ml of lyophobic colloid. To this, I will add lyophilic colloid. Some X mg of lyophilic colloid is being added. Okay, it is been stabilized by forming a solvent sheet. To this, to get it destabilized, I will add now 1 ml of 10% NaCl. Even though I add 1 ml of 10% NaCl, the above colloid is not getting destabilized. Okay, now what is happening here? Previously, if we add NaCl, it will get destabilized without addition of lyophilic colloid. If we add NaCl to the lyophobic colloid, it will get destabilized. Now, due to addition of lyophilic colloid, it will form it is protecting the lyophobic colloid to get destabilized. Okay, even though you add NaCl, that is 1 ml of 10% NaCl, this lyophobic colloid is not getting destabilized. Not getting destabilized means we need to represent that destabilization in the form of color. So, how will you represent? The color of lyophobic colloid when it is in stable form is red color. So red color is the color of lyophobic colloid, stable. Okay. Then the color of lyophobic colloid when it is forming a D-stable particle, then it is represented like this. Okay, the color of lyophobic colloid will be like so violet color. So this will be the color of destabilized lyophobic part. Destabilized means they form aggregation. The particles are forming aggregation. So violet color, that is unstable. Now the definition, we will try to see the definition. So by addition of, so we saw here, by addition of this x mg of lyophilic colloid, your lyophobic colloid is being stabilized. The lyophobic colloid is gold colloid, hence the name came gold number. So the name is gold number because you are using gold colloid here. Okay, so the lyophobic colloid is being stabilized by the addition of lyophilic colloid, even though you add electrolytes to destabilize this. So that amount of lyophilic colloid added to stabilize or to prevent the color change, to prevent the amount, we will try to write the definition here. So, okay, the amount of lyophilic colloid. So the amount of lyophilic colloid added to the solution to prevent the color change. Prevent the color change. We don't want this to happen. To prevent the color change from red to violet of 10 ml of gold colloid, gold salt. We call it as a gold salt. Okay. To prevent the color change from red to violet of 10 ml of gold salt upon addition of 1 ml of 10% NaCl. This is called as gold number. This how the definition is being created. Okay, so you can clearly see the definition here. So if you have any doubt, just go back and listen once again how I created this definition. So I just read out the definition. The definition says is amount in mg of lyophilic colloid required to prevent the color change of your gold colloid from red to violet upon addition of 1 ml 10% NaCl to that gold colloid. That what the definition is. I hope you understand. Thank you.